Welcome to this video tutorial. It's interesting that you are here.
Recovery. Why, I want to ask, why is checkpoint done periodically? Why is checkpoint done periodically? Can anyone give me the answer? Anyone? Can you indicate? Okay, David. Okay, to be able to capture the different transactions at different intervals so that, you can avoid the loss of transactions or the different operations carried out. Okay, I want to be certain that everyone is in the same pace. All right. Okay, let's move on. So at this point, want to move on to another topic. And of course, very wonderful topic, parallel and distributed databases. That's the next topic we are discussing now, parallel and distributed databases. For today, we are going to concentrate on the first one, which is what? Parallel databases. Parallel databases. Okay? So with this, want to see the outline quickly. I hope you can see me. You can see my screen as well. If you can do that, please just give me a thumb up on the screen. Okay? All right. So the first outline is introduction and definition of the topic, features of parallel databases, architecture of parallel databases, and of course, the last not the least, significance of parallel databases. Please, I want us to be all together, make it interactive. While I talk, I'll ask you some questions, not just you asking me questions alone, okay? All right, let's move ahead. Parallel databases. To start with, remember from your SS1, you've talked about databases, types of databases, models of databases, different things about databases, and even the last topic is still about what? Database. Remember how to recover, how a database can be recovered from crash. So at this point, this is something else in addition to that, parallel and distributed databases. What is this one talking about? Now, in the house, there's a relationship that's going on between you and your mom, between your mom and your dad, between your mom and your dad and you. Now, you discover in the family, there's a dad, there's a mom, and you know that there are certain things you move from your dad, from your mom to your dad. You may not just go to your dad directly. Rather, you move from your mom to your dad. Maybe few things, you can go straight to your dad. It's like that naturally. Some persons cannot approach their mom. Rather, they will go to their dad to request for a particular thing. This is natural thing about life. So, here, what are we trying to do? Want to see the operations that are taking place in a database. For example, when we discuss operating systems in SS1, we talk about types of operating system. Is it not? There are operating systems that can allow you to do more than 2 tasks at the same time, 3 tasks at the same time. Likewise, there's an operating system that can allow 2 users, 3 users to do things simultaneously. We talk about multi-threading, single user, multi-user, and all that, if you remember. Okay, now in a database operation, is it possible that in the existence of a server or even a client system, that 2 operations can be going on at the same time? Even if in a small network, maybe a family network, a house, you have 2 systems connected to your server. Is it possible that 2 operations can be going on without disturbance? Not from a single person, but from maybe 2 persons, 3 persons. You are carrying out different operations without any problem. Is it also possible that individuals can use different systems at different points and be doing certain things they want to do without any problem, but all of them are still linked up together? This is what we are trying to discuss here. And so, parallel database or databases. We are talking about what? That is a system that seeks to improve performance through parallelization. Parallelization, talking about what? Parallel. when you talk about line, okay, when you talk about line, in mathematics, geometry, you say parallel lines. I'm sure that is what it is. Eh? It can be this way. It can be this way. I'm sure that's a parallel line. In other words, this one is moving and the other one is moving without interference. No issue. But if they are moving this way and the line is coming this way, of course, there will be what? Interference. Am I right? So we are liking this to operations in the database. All right? So whereby two operations, three operations concerning a system can be carried out without any issue by a parallel means. By what? A parallel means of structure. And so we are saying that performance, it seeks to improve performance through parallelization of various operations. That is the various operations that is being carried out, such like loading data, building indexes, and evaluating queries, or maybe any other operation that want to be carried out. This can be done without, issue within the database itself, or even to the operations itself. And so when I am a user, you are a user. Now I am talking. If you are talking the same time, there's going to be interference. Am I right? No one will be talking, no one will be hearing each other. But if I'm talking, you listen while you talk. At this point, there's no interference. But if I'm talking and you are talking, it means that there's no parallel system. It has not been designed, the communication system now, it has not been designed to work on a parallel form. So if I'm talking, you cannot be talking at the same time. Why? There will be interference. And that cannot be what? Parallel. But if I'm carrying out an operation now, you are also carrying out another operation, but everything comes to the same center. It means that there's parallel operation without any interference. Maybe loading of indexes. You can be building indexes of a particular database. On the same database software, you are building indexes, like we talk about index, while I'm doing another thing without any issue. That's what we're talking about, what? Parallel databases. Right? So the next thing is about the features. Features of parallel databases. What is it all about? We say it uses what? Shared nothing, shared memory, shared disk architecture. We'll soon be talking about architecture of this particular what? Database. So it makes use of what? It makes use of three different structures: shared nothing, shared memory, and shared disk. Is someone with me now? So these are the the feature, or say characteristics. You can use the word features or characteristics. So the other one is communication cost is small. Communication cost is what? Small. I'm sure you know what that one should be talking about. Why do we say communication cost is small? Let me bring you to this point. Because all these things will be in a common room. Like, for example, you are able to connect to the internet now because you have a network in the house. There might be another system, 2, 3 systems connected to the same network right there. Are we here? So all of them, they're in a common area. You will not spend much money in terms of maybe cable or any other amenities or component that want to be working, that want to be added together. So you have what? Less expensive, right? The other one is machines are physically close to each other. You can see the explanation I'm talking about now. They're in a common place, a smaller location. And of course, if that is the case, it means that the machines are connected with high-speed LANs and switches. Of course, you know about switch. That was treated in networking, computer science last term. We are still going to talk about that in data processing, networking also. So what are we saying here? That they are in a common location. And because they're in a common location, the possible means of connecting the systems is what? LANs, if you remember what LAN is all about. And then switches can also be used to extend more than 3, 4, 5 systems. This is about the features of a parallel databases. The next thing is about architecture architecture. That is the structural design of these what parallel databases. And so the first one, if you remember from the first point of the feature or the characteristics, is what? Talking about the various architecture in which the parallel database make use of. Now, we are saying number one is shared memory. What's about shared memory? For example, your dad in the house is responsible for the upkeep of the entire family. What does that mean? Your mom, he is responsible for the upkeep of your mom. All ramification. He's also responsible to the children in all ramification. Whatever comes to be are supposed to be the amenity used in the house, he's responsible for it. I don't know if someone is with me here. And so it's like it has shared functions. He will be thinking of what to do to the mom, he'll be thinking of what to do to the children, even the house itself will be thinking of what to do. And so Mr. A, Mr. B, we go to the dad, to the mom. Look, I'm in need of this. The other one will say, I'm in need of this. Your mom will be telling your dad, I'm in need of this. So he will go back to himself and begin to think, how do I do this to my wife? How do I do this to Nkechi? How do I do this to Collins? And all that. One person is sharing his memory to what the task is supposed to do to every other person. I hope someone is with me. All right, so we're talking about shared memory. What's so special about this? You have a system there. Ejoku has a system. David has a system. Chika is having a system. Now, these systems can be connected, and all the systems connected are all operating the same database. And so, system A, system B, system C, that is the aspect. You can see processor. Processor, if you see that of the PC, I can use the word PC or I use the word processor. You see the upper side, processor, processor, processor. So the processor is representing individual systems. And this individual system processor are connected through an internet connected bus or network. It is through the network. Now they are linked to a common memory, which can be referred to as what? The global memory here. They are linked to the global memory. In other words, they are sharing one memory. For example, I'm giving a diagram of 3 systems here. It means that the 3 systems are sharing from one single memory. So one single memory serves the 3 of the systems. Likewise, from the systems, they are connected to their individual memories, yet shared still, are all linked to the what? To the memory. I hope someone is with me. So each CPU have a common interface through the network, and all of them can access a common what? Memory. A common memory. A common memory. From the memory, the disks can also be what? Connected to it, are also connected to it. So what are we saying here? 1, various CPUs are connected to a common memory through a common interface, what? Known as what? The interconnected network. And of course, through the common memory, you can access the various disks, the various disks. Now, they also have advantages and disadvantages. Now, by the time the note will be uploaded for you, not this week, but likely next week, will be uploaded for you, you'll be able to see the good side and the bad side. The good side and the bad what? Side. And so here, it means that the CPU can access, all the CPUs can access the common memory. Simple. 2, it is easy to access data. It is what? Easy to access what? Data. That is to say, there will be no difficulty in trying to access each of them, not to gain access to data. Easy access to data. 2, a common memory is shared. Then on the disadvantage side, if more hard disks or if more CPU is added to this architecture, it may get to the point whereby there will be what? You know, what we call like scalability. When we say scalability, what does it mean? Ability to pass through, then go through and pick something. Like you have a door in your house. Can 3 people pass through your door at the same time? Okay, can even 2 pass through the door at ease? No. The interface is meant such that one person will pass at a particular time. And so if most CPUs keep increasing and all of them are using the same memory, it means that there will be what? Some challenges in what? Scalability. That's for that. So you find more in the note when it will be sent to you. All right? Okay, let's move on. The next one is parallel architecture. But before I talk about parallel architecture, is there any confusion in the first one? Okay. Question, please, quick. Participants. No, since we are discussing, that means it's a question that will be answered along the line. Okay. So we'll answer who typed the question. We'll answer your. Okay. Anna, your question will be addressed as we move on. We are discussing, that is the topic we are discussing now, right? Okay. You can see already, I've just finished talking about shared memory. The next thing is shared disks. So it means that your questions is not a question to say. All right. So shared disks. What are we talking about shared disk? The other one is shared memory. Now we are talking about shared disk. What should be, going on in your mind right now? It means that the point of discuss is the disk, which is what? The hard disk. All right. And so in this one, the system, of course, shared disks. In other words, the multiple processors, like you can see, like I said before, the multiple processors still having their own memory directly connected with them. So each CPU is directly connected to its own memory. Note this now. Each CPU is directly connected to its what? Memory. And now the CPU through an internetwork surface share the disk. They share the disk. It means that if this
Do click the subscribe button.
This is processor B or A or C, it can have access directly to disk B or disk T, for example, since they are in a common interface network. It means that processor C or B can have direct access through the network to disk C. This is what we are talking about now. And so here, the multiprocessors have access to what? To the disk through interconnected channel or bus. And each processor has its own local memory. Note that the processors, multiple processors, have connection to what? To the what? To the disk. The disk. You can say the hard disk. And each of them has its own memory connected directly. All right, the last part I said each processor has its own memory so that data sharing is efficient. Data sharing is efficient. On the other one, they have what? They are sharing a common memory. But in this one, they are sharing a common disk. Okay, like what you have on the screen. One, note this. Shared disks. Shared disks. You see in the middle here, this interconnected surface here is where the disks are all connected to. And then on the upper side, the processors are connected to the network. Are you with me now? Now, about how many of you now? About 75 or thereabout of you. Am I right? are all connected to me now. Are you getting it now? You are all connected, but you have a memory in your system. Are you there now? You are not. You are not sharing memory. Your system is having its own memory, and the CPU is running there. But you are all connected, linking to my own system. Of course, you are able to see what I'm doing. So your CPU is directly connected to your memory. All right, and then you are having access to me now, which is what that is for the other part, which I mean on the other side we'll be talking about. But what I'm saying here now, note that your system is having a memory, and now through a network you are accessing what I'm doing now. Through a network you're accessing what I'm doing now. So the interconnected network serves as an interface whereby you are able to see what I'm doing through my own disk. Are you there now? And so another person can access my disks. Another person can access my disks. I can also decide to do so that me right now, I'll be accessing what you are doing, log into your system, and I have access to your disks. In other words, you can see what I'm doing inside my hard disk. You can see the information that I stored inside my hard disk. I can also see the information stored inside your hard disk, which is what? The database. Note that. So they have a common interface to all the disks. The disk is a common interface, having a common interface through the network. So every system can access the disk at different intervals without any challenge. One, I said, a shared disk system uses multiple processors, which are accessible to multiple disks. In other words, the processors can have access to the different disks through interconnected channel. And each processor has its own local disk. Its own local disk. Local memory. Its own local memory. Like I said before, local memory. But they have a common, they can access any of the disks. Lastly here, each processor has its own memory so that the data sharing is efficient. And then the system built around this type of system are referred to as clusters. The word called is not proper here, but should be known as clusters. Are known as clusters. So this is about what? Shared disk system in a parallel data basis. Shared disk system in a parallel data basis. Now, in this case now, one of the important things here to note as an advantage is that their memory is directly connected to them. In other words, it's going to speed up the rate of operation. So it'll be increase in processing speed. Is someone with me now? Are you guys there? So there'll be increase in processing speed. All right. Now, the processors are having a kind of a backup power to also carry out their processing. No, someone is asking you, Chika, I'm explaining to you, but you cannot access. But what I'm saying is I can set up the system. You have a system with memory and CPU. But what I'm saying now is that you're accessing what I'm doing through interconnected network. But I'm not sharing my disks. However, I'm using that phrase now to refer to what I'm trying to talk about. I'm not sharing my disks. Well, it's a situation whereby I now make or enable you to see my disks. I now enable your own system so I can see your disks or another person can see your disks. It becomes what? Share the disk. Are you there now? It becomes what? Share the disks. Okay? All right. Now, I made mention of one advantage. It's robust in accessing or carrying out operations because the memory is directly connected to it, right? The advantages and the disadvantages you see more in the notes, right? PowerPoint document that we are seeing. Yes, you cannot see the PDF or e-note now. Okay, you can swap your screen. We don't have the idea. You can swap your screen if you want to see in their phone. Yes, if I configure your phone, as long as you are connected together. If I configure your phone that I can access it, of course it can be done. Right? Don't dare me. Don't dare me. I told you where I'm falling down from. Where the environment I'm coming from. You know, one time, sometimes, like especially your first time when we're meeting for the first time, you're like saying, who is this guy? What's it? Where is he from? Why is it like this? I told you, like from a different environment. You know, have chewed ICT to a point. I may not be the best, but I've chewed ICT to a point so that I can do something that you'll be surprised. But that's not what we are discussing here, right? So any device that's configured to be accessible, I can get it done. All right, even if it's not configured, but that's not the area where I decide to base on because it's criminal. It is more of criminality. I can, even if without configuring it, I just need one or two things in your system to gain through the internet without you giving me. I'll log into your system and you see me working even now. But that's not the area I decide to go in for. You know, I want to be on the good side, the positive ends. You know, just give me a thumb up for that now. For me, deciding to be on the positive side. Don't you like that? Hello. All right, let's carry on. So, what are we saying in summary of this? Shared disks. Yeah, guy. Yeah, see you. Devil. All right, so we are saying that there's a common interface. A common interface is the internet network. And what is shared here is the disk, right? With them having their own memory, right, on the various systems. That's about shared disks. It has disadvantage also, but we're going to see that in the e-note when it will be sent to you. But from what we are discussing here, what do you think should be a disadvantage to this, please, before I move on? Today's class is brief. You know, I try to shorten it so I will not be, fighting to cover up the time. Who can say something? What will you think that should be a disadvantage here? Yeah, can someone give me an answer to that? Who is ready for that? What will you think should be a disadvantage to this? Anyone? Crack your brain, please. Look the inside you. Should I call someone? No. I want someone on bias. Okay, David, you want to tell us something?
Okay.
All right.
It might be slow. It might be a slower process because some systems or processors are not as fast as the other ones.
Okay. Yeah, you're on the line. For real, for real. The memories and the disks are what? The memories and the disks are they the same? No, please. Memory and disks are not the same. The word disks is referring to your what? The hard disk.
I didn't say disk. I said the processor might not be the same.
Not you. You are done. In fact, I got you. Somebody's typing a question for me through the chat. All right, Dave. You are good. You are good. You are good. Yeah, you are good. Someone type a question through the chat, and he's asking, or the person, who was the person? Okay, Fezwe, right? He's asking. She's asking, am I right? Rosie. Okay, not Fezwe. Ask whether the disk is it the same thing with memory? No, there are two different things. Remember, RAM. RAM is referred to this is what we are referring to this memory. All right, not hard disk, please. Okay. All right, let's move ahead. Let's move ahead, guys. If there's no other question. Okay, the last not the least is shared nothing disk system. You have not muted someone. Shared nothing disk system. This guy is a selfish man. This architecture is very selfish. He doesn't want collaboration. You know, he doesn't want partnership. Mind your business, I mind my business. Even if we have a common interface of network, but don't disturb me. I will not disturb you. That's about this guy, which is what? Shared nothing disk system. All right? No disk is shared. Nothing, no memory is shared. Everybody on their own. OYO. Eh? Oyo. Okay. There, however, there is an internetwork surface. Why? Because it is the same firm that own this particular database system. But this one is more deployed with what? With a company that's having different different branches. You know, maybe right now, with my contact in India or in Ireland, if I want to you know, do something, maybe I can be the branch manager right here, and we can be running a database. I'll be independent. Office B or C out there can be independent, but it's a common company running this what? Database system. And so it's the same company, but my own unit here, my branch here, in which I'm the branch manager, I'm running everything. My system is having a disk, my server is having a disk. There's a server for me with my disk, with my memory. I'm working what I need to do. Another branch is like that, another branch is like that. This is the kind of a system you may see in banks. You know, Access Bank, you have branches, different areas of the state. You know, but somebody can be, you here in your branch, let's say in Port Harcourt, can be accessing the records or the transaction so far of, let's say, Mr. Amukai Fanyi, what so far he has been doing in his account, all right, here in Port Harcourt. And somebody in Lagos will be doing that similar thing with a different branch there without any issue. You don't know what is happening there. The person here does not know what is happening there. But it's the same bank. Are you with me now? You are the same bank, all right? This is what we are talking about. The same company. Until when there's a need to do what? To maybe exchange data. Because the headquarters will definitely do what? Demand the information from the different branches. And so at that point, the needful can be done. But the branches are operating independently. This is about what? Shared nothing disk system. And so what are we saying here? That each processor in the shared nothing system has its own local memory and local disk. Local memory and local disk. Then the processors can communicate with each other through a common interface, which is what the intercommunication network or channel. No? So any processor can act as a server to serve the data which is stored on a local disk. All right? Any processor can act as what? As a server, right? But in terms of the shared nothing, shared disk or shared memory, we discover there's some things that distinguish each other, all right? Or distinguishes each other, right? In this case now, all the three properties are all intact in a particular system, you know, and they can serve as their own server as well as their own workstation or client. Shared nothing disk system. All the server, all the client, they are on their own. They share nothing in common. They share what? Nothing in common. The branch office in Port Harcourt is operating independently. All the clients, all the customers in Port Harcourt branch, they are all there in my own server. I'm managing them without any issue or interference with any other branch in Port Harcourt, in Ireland, or in India, or any other place, right? They are all on their own. But because they're common in the same company, there is what? A common interface through the internet work. They don't share anything. They share nothing. Just like maybe in the house, your dad is there, your mom is there, you, the children, you are there. And your dad will just decide to say, look, Henceforth, I'm not taking any responsibility of anybody. Please, mom, take care of yourself. The siblings, whether you are 2 or 3, take care of yourself. Anything you want to do for yourself, go and get it done. How to source for money, how to take care of yourself, how to educate yourself. Everybody's independent. But you are still bearing the same name. Hello, guys. You are still bearing the same name, the same family. If it's Ogbonna, Chimzi, all of them are bearing the same family name. But everybody is on their own. You fend for yourself. All right? So this is what we're talking about in shared nothing Dixie system. Because it is the same company. They share there's nothing yet in parallel database because, of course, it is the same company that own these different branches. Should the headquarters of, let's say, Zenith Bank in Lagos not have a connection with the branch in Port Harcourt or in Abuja or any other place? No. Or even if it's across the country, there still need to be what? Interconnection, right? Okay, this is about shared nothing. So you can see that here they will still be talking about advantages and disadvantages. So you see more of this in your notes, right? In your notes. But I'm going to ask you some questions. I'm going to ask you some questions. All right. Hello, guys. Don't mind us here. Yeah, please, can you give me something here? I want to get a response from you. Any other question? Any other question? Any other question? Another question. You can see my evaluation questions there. Another question? All right. I want 3 lucky people to give me answers to the 3 questions here before the last one, theory. Anyone is free before I call on someone. Three lucky people. Of course, you know, all of you cannot answer the questions. The good number of you. So who wants to answer? I'm not calling anybody. Who wants to answer? Hello? Who wants to answer? Okay, if there's nobody that's ready to answer, I'm going to ask somebody. Please go to, I want to see my guys in the A class. The A class, I've been seeing B, C, and D. 1C. Okay, number 1, C. Let me see the person. Let me get the person. Okay, Martins. Okay, yeah. You are good. You are good. You are good. You are good. All right. Yeah, number 2. Number 2. Anyone? Number 2. Who is that? Iguagu. Iguagu for number 2. Am I right? You said data is easily accessible to any processor. Advantage of which parallel architecture easily accessible. Shared memory. Shared memory or shared? Which one did you say? Shared memory. Okay. Are you good? Should I give you a thumb up? I'll take you back to the question. Okay, let me hear from another person. Shared memory. Number 2, A. Shared disk. Okay. Answer for yourself now. Look at the shared memory. I mean shared disk. Shared disk. All right. So for number 2, data is easily accessible to any processor. Where? The shared disk. The shared disk. All right. Okay. So thumb up for you. All right.
Okay, thank you for being there. Thank you for coming to our channel. Do make sure you click on the subscribe button to possible get the alerts for uploaded videos. See you. Thank you.